June 6, 1944, dawn broke gray and violent over the English Channel. Waves rolled like steel walls, slamming against thousands of ships stretched from horizon to horizon. The sea itself seemed alive, crawling with landing craft, destroyers, and transports so dense that a man could look in any direction and see nothing but war. On the decks, young American soldiers clutched their rifles, staring toward a distant coastline shrouded in smoke. That was France, and beyond it, the fortress of Hitler's Europe. The air thundered with the drone of bombers overhead, while the water below churned with the wakes of invasion barges pushing toward Omaha Beach. But behind those men, far from the gunfire, another army worked in silence. Engineers, welders, and construction crews, men in grease-stained uniforms, were assembling something no enemy could have imagined. A floating harbor, a highway across the sea. While the Germans prepared to fight men, they never imagined they'd have to fight American ingenuity itself. What began that morning was not only the greatest invasion in history, but also the most extraordinary engineering operation ever attempted under fire. The story of how that floating highway came to be begins years before that stormy dawn. Long before the first landing craft touched the sands of Normandy, Allied planners faced a question that seemed impossible to answer. How do you invade a continent without a port? Ports were lifelines. They fed armies, unloaded tanks, fueled trucks, and carried back the wounded. Every past invasion in modern warfare had relied on capturing a deep-water harbor within days. But the Germans knew this too. Along the French coast, from Cherbourg to Calais, they fortified every major port with concrete bunkers, heavy artillery, and minefields that could tear apart any assault. By late 1943, as the Allies prepared for Operation Overlord, the issue of supply had become the single greatest obstacle. Intelligence officers warned that even if the landing succeeded, the beaches could turn into graveyards for lack of fuel and ammunition. General Eisenhower's staff estimated that the invasion force would need nearly 12,000 tons of supplies per day just to survive the first week. Without a port, those tons had nowhere to go. British engineers were the first to propose something radical. Bring the port with you. The idea, whispered in planning rooms and naval workshops, sounded impossible. To tow artificial harbors across the English Channel and anchor them off the invasion beaches. Prime Minister Winston Churchill, himself a former First Lord of the Admiralty, saw genius in the madness. He issued a blunt order that became legend in engineering circles. Piers for use on beaches. They must float up and down with the tide. The problem must be solved. The concept soon gained a name: Mulberry. It would be an artificial harbor system made up of floating concrete caissons, steel roadways, and massive breakwaters, each piece towed from England like a fleet of puzzle parts. When assembled, it would form a fully operational port, capable of handling hundreds of ships and thousands of vehicles. Across Britain, secrecy surrounded the project. Hundreds of construction sites appeared almost overnight. On the Thames, in Wales, in Scotland. Workers were told only that they were building special floating units for a classified naval purpose. Few knew that those blocks of concrete, some the size of apartment buildings, would one day be part of the greatest logistical feat in military history. For the Americans, the challenge was different. They needed to master the British concept and reproduce it at an industrial scale. Engineers from the U.S. Army Corps studied prototypes, improved designs, and built floating roadways strong enough to bear tanks. In total, over 600,000 tons of steel and concrete were used to construct the American components. By early June 1944, the floating harbors, Mulberry A for the Americans at Omaha Beach, Mulberry B for the British at Gold Beach, were ready. But no one yet knew if they would survive the sea, the tides, or the war itself. In the months leading up to D-Day, southern England became the world's largest construction site. Shipyards, docks, and beaches were filled with engineers working under floodlights, building concrete giants known as phoenix caissons. Each one weighed thousands of tons and stood taller than a four-story building. Welders shaped the steel roadway sections, called whales, while others built floating pontoons named beetles to support them. Every piece was labeled, numbered, and tested. Each team had a specific role, and yet most workers had no idea what they were truly constructing. Security was absolute. The word Mulberry was never spoken outside closed rooms. To the public, it looked like the British and Americans were simply producing more invasion barges. Among those supervising the effort was Major Alan Beckett, a British engineer whose innovative, flexible bridge design would allow the Mulberry roads to rise and fall with the tides without breaking. American engineers soon adopted his system, modifying it for heavier vehicles and stronger Atlantic swells. The collaboration between U.S. and British design teams was extraordinary, a union of precision and power that would soon define the invasion's success. On paper, the idea still seemed almost reckless. No one had ever built an artificial harbor, towed it across open sea, and assembled it under combat conditions. Yet there was no alternative. Capturing a major port early was too dangerous. The Allies decided to gamble on engineering. By May 1944, rehearsals began off the southern coast. Tugboats practiced hauling massive caissons through the channel's unpredictable waters. Roadway sections were connected and tested under heavy load. Everything depended on timing. The tides of the Normandy coast were notorious, shifting as much as 20 feet twice a day. If the Mulberries couldn't adapt, the harbor would tear itself apart. When Eisenhower visited the test site, he watched the roadways flex and rise with the waves. He turned to his staff and said quietly, "This may be the key to it all." Behind the scenes, the logistical plan took shape. Once the first wave of troops secured the beaches, naval construction units would follow, towing the harbor pieces across the channel and assembling them within days. The goal was simple but staggering: to unload over 7,000 tons of supplies per day directly onto the beaches. On June 5, 1944, as Allied troops prepared to sail, those massive concrete blocks waited silently along the southern coast of England, like dormant beasts ready to cross the sea. When the invasion began, they would follow. And when they reached France, the world would witness an engineering miracle that no German strategist had ever considered possible. When the invasion began, the world's attention was on the beaches. Cameras captured soldiers storming through surf and gunfire, but few recorded what happened behind them in the following days. A quieter, equally crucial battle fought with cranes, winches, and welding torches. American engineers and naval construction crews, many from the U.S. Army Corps of Engineers and the Seabees, became the invisible backbone of the invasion. These men were not trained for frontline combat, but their work determined whether the front could survive at all. Every bolt, cable, and floating platform they placed meant fuel, ammunition, and reinforcements could reach the troops fighting beyond the dunes. They worked without pause. Bulldozers pushed aside wreckage from the beachhead as engineers began assembling the first sections of the Mulberry Harbor. Tugboats arrived, towing the enormous phoenix caissons, anchoring them in a wide arc to form a breakwater against the channel's waves. The sight was surreal, a port appearing out of the sea itself. Within days, the Americans connected floating pontoons and steel roadways stretching more than a mile from the water to the sand. Trucks began to roll across those trembling bridges as if driving over solid ground. The harbor swayed and creaked under the weight of tanks and heavy artillery, but it held. What made it extraordinary was its simplicity. Each piece was modular, designed to be replaced or repaired quickly. Waves could rise 20 feet, yet the flexible roadways bent with the sea instead of breaking. To the Germans watching from the cliffs, It looked like the Allies were building a city offshore. Naval reports described the scene in understated terms. Traffic moving smoothly over floating causeways, port fully operational. In truth, it was one of the most complex logistical feats in modern warfare. The engineers rarely received headlines or medals. Their success was measured in tonnage, in how many supplies reached shore, how many tanks drove inland, and how many men stayed alive because the lines never broke. Each day, the floating harbor grew busier. By mid-June, long convoys of Liberty ships were unloading supplies at the Mulberry docks. Cranes lifted vehicles straight onto the floating piers, where they rolled directly to the front lines. But far away, deep inside France, German commanders had begun to notice the impossible, and they could not believe what they were seeing. From their bunkers along the Normandy coast, German observers watched the sea in disbelief. For months, the Wehrmacht's intelligence officers had studied Allied logistics, certain that any large invasion would collapse without a captured port. Their Atlantic Wall fortifications were built around that assumption. Now, through their field glasses, they saw something they had not predicted: an entire harbor floating where none had existed days before. At first, many assumed the Allies were building a temporary bridgehead, but when convoys began unloading cargo ships directly onto the water, German commanders realized this was no improvisation. Reports flowed back to Berlin describing large concrete structures and mechanical piers extending from the ocean to the beaches. One officer compared it to watching an island rise from the sea. In headquarters, disbelief turned to concern. German engineers struggled to understand how the Allies had transported such massive structures across the Channel under constant risk of detection. To them, the scale of coordination seemed impossible. The Luftwaffe attempted reconnaissance flights, but poor weather and Allied air superiority kept their pilots from gathering clear photographs. All they could confirm was that the Americans had built something entirely new, and it was working. Captured German documents later revealed the shock among coastal divisions. One message from a senior officer read simply, "They have brought their own ports." On the ground, the Mulberry's presence changed the rhythm of the war. Each day, new columns of American vehicles rolled inland. Supply shortages, the bane of military campaigns, were vanishing. Ammunition, fuel, and food arrived faster than German forces could react. What the Wehrmacht had once seen as a narrow beachhead was quickly becoming a permanent foothold on the continent. For German troops defending Normandy, it was psychological defeat as much as military. The Atlantic Wall had been built to repel a landing, not sustain a siege. Yet now the Americans were doing both, landing and building faster than the Germans could destroy. General Erwin Rommel, inspecting the aftermath weeks later, would remark privately to his staff that no defense could have stopped a power capable of constructing harbors out of the sea itself. That silent marvel of engineering was about to face its greatest test. Nature was preparing to strike harder than any army. June 19, 1944. 2 weeks after D-Day, the English Channel, calm for days, began to change without warning. Winds rose to gale force, waves climbing higher each hour until they towered over the floating piers and breakwaters of the Mulberry Harbors. The barometers dropped sharply. What the meteorologists called a summer storm was, in truth, the worst to strike the Channel in 40 years. For 3 relentless days, the wind screamed across the water at nearly 65 miles per hour. Anchors snapped, pontoons tore free, and concrete caissons shuddered under the pounding surf. Ships that had survived the invasion now found themselves helpless, driven onto the beaches or smashed against the floating docks. The Mulberry at Omaha Beach, the American harbor, bore the full force of the storm. Engineers raced through the night to reinforce the moorings, welding and chaining sections as the seas tore them apart. Trucks skidded on swaying roadways, cranes toppled into the water. It was no longer a battle against an enemy, but against nature itself. By dawn on the third day, parts of the British harbor at Arromanches, Mulberry Beach, were destroyed. The American Mulberry fared even worse. Dozens of Phoenix caissons cracked and sank, their jagged tops still visible beneath the waves. One observer later wrote, "It looked as though the sea had eaten the harbor whole." For Eisenhower's command, the loss was devastating. Months of planning and labor, gone overnight. Allied logisticians warned that supply lines would collapse. The beaches were still the only lifeline for over 1 million men now fighting deep in Normandy. But even as the wind roared and the sea swallowed the work of thousands, American engineers refused to retreat. They worked knee-deep in icy water, hammering, welding, and salvaging whatever could still float. The storm destroyed most of the American Mulberry, but not the spirit of those who built it. Reports from Omaha that night described men sleeping in wrecked trucks, waking only to secure another pontoon. They called themselves the Silent Army. Their mission hadn't changed: to keep the flow of war alive, one bridge at a time. When the storm finally broke, the beaches were unrecognizable. Yet among the twisted metal and wreckage, the Americans found enough to rebuild, enough to turn loss into adaptation. The next phase of their ingenuity would redefine how the Allies supplied the war in France. When the storm finally passed, the scale of the damage became clear. The American Mulberry Harbor lay shattered, its breakwaters broken, its piers scattered for miles. Engineers waded through the wreckage, marking what could be salvaged. The harbor itself was gone, but the mission was not. In a moment that defined the American approach to war, the engineers decided not to rebuild the harbor in its original form. Instead, they adapted. The surviving pieces were reorganized into a new kind of system, a hybrid of floating causeways and direct beach unloading zones. The Mulberry had been designed to make supply efficient. Now, it would make supply unstoppable. The new plan relied on speed, improvisation, and endurance. American landing craft began to act as mobile ports, delivering supplies straight to shore. Engineers used bulldozers and cranes to reinforce beachheads, building ramps and stabilizing the sand for trucks. Damaged pontoons were turned into makeshift docks, while captured German materials were reused to anchor new platforms. Within days, traffic resumed. Ships once again lined up offshore, unloading cargo in a steady stream. Despite the storm's destruction, the Americans managed to land more than 1 million tons of supplies over open beaches in the following weeks, an achievement even greater than the Mulberry's original design. What had begun as a disaster turned into a demonstration of resourcefulness. The Germans had expected the storm to cripple Allied logistics. Instead, it only proved that American ingenuity could adapt faster than the enemy could react. Reports from German intelligence after June 1944 show growing confusion. They noted that despite the loss of the artificial port, supplies continued to flow without interruption. Rommel's staff, already struggling with the Allied advance, could not explain how such a massive army remained fully supplied without a functioning harbor. The answer lay not in blueprints, but in mindset. Every truck driver, crane operator, and construction crew became part of a living supply chain that never stopped moving. Even without Mulberry A, the American beach at Omaha remained the beating heart of the Allied invasion. By late July, when Operation Cobra launched, the breakout from Normandy, fuel, ammunition, and tanks flowed across those beaches faster than at any port in Europe. The floating highway had been broken, but its purpose endured. From destruction came innovation. From innovation came victory. By midsummer 1944, the Normandy coastline had transformed from a battlefield into the world's busiest harbor. without a single permanent dock. What began as a desperate improvisation after the storm evolved into one of the most efficient supply operations in military history. Every day, ships anchored offshore and unloaded everything the Allied armies needed to fight across France, from tanks and trucks to canned food and gasoline drums. Bulldozers pushed supplies into organized depots along the sand. Engineers maintained a rhythm so relentless that even German artillery barrages couldn't slow it for long. Between June and November 1944, over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies came through the Normandy beaches. Much of that passed through the remains of the American Mulberry at Omaha. Despite its partial destruction, it became the logistical heart of the Allied advance. To the Germans, this defied logic. Their strategists had believed the Atlantic Wall would hold until reinforcements could arrive. But now, they faced an enemy whose strength seemed to grow with every passing day. Allied columns advanced inland, well-fed, well-armed, and seemingly endless. Captured German reports from the period show both frustration and disbelief. One intelligence summary noted, "The Americans possess an inexhaustible flow of materiel. Our defenses crumble under the weight of their supply." Another described the beaches as industrial landscapes, filled with cranes, vehicles, and fuel lines stretching to the horizon. The Mulberry concept had not only delivered supplies, it had delivered momentum. In warfare, momentum is everything. Once an army gains it, even weather, terrain, and opposition struggle to stop it. The Americans had found a way to turn beaches into ports and storms into lessons. From that point on, the question was no longer whether the Allies could hold Normandy. It was how far they could go. By August 1944, the beaches of Normandy were no longer temporary. They had become permanent arteries of an advancing army. Convoys of trucks rolled inland in endless columns, the beginnings of what the soldiers called the Red Ball Express, a non-stop supply network that pushed fuel and ammunition all the way to the front. Every gallon of gasoline, every ration crate, every artillery shell that reached the troops had likely touched the floating docks or beach ramps at Omaha, American. Logisticians later called it the miracle of movement. What impressed them most was not just the quantity of supplies, but the rhythm, a constant pulse of ships, cranes, and engines that never ceased. The entire operation was proof that industrial efficiency could be translated into battlefield power. The Germans, watching from retreating lines, could only marvel. They had fortified France for years, believing geography itself would protect them. Yet now, geography had been conquered by engineering. The Atlantic Wall, built from concrete and fear, had fallen to a nation that built concrete to float. When U.S. commanders reviewed the campaign months later, they understood that victory in Normandy had been more than a matter of courage. It was a triumph of logistics, of foresight, design, and relentless adaptation. The floating harbor at Omaha, even in ruin, had done its job. It proved that no obstacle, natural or man-made, could halt American supply and determination. The lessons learned from Mulberry shaped the remainder of the war. Allied planners used its principles to design portable bridges for river crossings, floating docks for Pacific invasions, and rapid construction systems that shortened every campaign that followed. For the Germans, it was a sobering realization. They had been outthought before they had been outfought. The Americans had not just invaded, they had reinvented the art of invasion itself. And in the surf at Omaha, where steel and tide once met, the remains of that floating highway still whispered the same message. Victory belongs to those who can build faster than others can destroy. When people remember D-Day, they often picture soldiers charging through smoke and surf, the chaos, the bravery, the loss. But behind that moment stood a quieter kind of courage. The men who built the Mulberry Harbor never fired a shot in anger. Yet, their work carried the invasion forward as surely as any rifle or tank. The floating highway at Omaha Beach symbolized what set the United States apart in World War II: the ability to imagine the impossible, organize it, and make it real. It wasn't just strength or numbers, it was invention under pressure. Every beam, every cable, every tide calculation represented a faith that human effort could outmatch chaos itself. The Germans saw in it something they could not replicate: a culture of improvisation and cooperation that turned blueprints into reality. For them, the Atlantic Wall had been the endpoint of logic, a solid defense. For the Americans, the sea itself became a tool. By the end of the war, that same mindset, build, adapt, overcome, had reached across 2 oceans. It powered airstrips in the Pacific, bridges across the Rhine, and supply routes stretching from Normandy to Berlin. Today, the remains of the Mulberry still rest off the coast of Normandy, half sunk and covered in seaweed. Fishermen pass them without notice, unaware that beneath those waves lies the concrete proof of how industry and imagination changed history. The story of the floating harbor isn't only about engineering or victory. It's about persistence, the belief that no problem is unsolvable if people refuse to stop building. In the end, that was the true weapon the United States brought to Europe in 1944, not just firepower, but the will to construct something greater than destruction itself.